Hey everybody, so continuing our analysis of trusses using the method of sections, this is a sort of tricky academic example. So here it's saying we want to figure out the axial forces here and here. And if we are, say, forced to use the method of sections, how do you cut a section through these two members? You could just go like this, right? And then if you did that, what do the sections look like? The free body diagram of the left section would look like this. Okay, and then this is BE, CE, CG, DG. And then there's also a load here and a reaction at pin A, I pick coordinates like this. Then at pin A, there's a reaction which I will decompose into X and Y components. Okay. And the other section would look like, the right side section would look like this. And there's a, let me finish drawing like other stuff here and here. Okay. Then there's going to be a load here, here, and a roller support here at K. Alright, so which of these sections would have less unknowns for analysis? This one has 1, 2, 3, 4, 5, 6. This one has 1, 2, 3, 4, 5. Okay, so maybe this has less unknowns than this side, but either way, we still don't have enough equations, because at best we could write 3 equations here, 3 equations here. That's not enough. So the strategy would be take the whole thing, right, the entire structure, and then for the entire structure, there are loads like this. And then there's a reaction at A and a reaction at the roller. Okay, so for the entire structure, you can write 3 equations to solve for these 3 unknowns. Okay, that's for a given load F. And then, since we know those 3 reactions, these would be known here. So now 4 unknowns left. But we can only write 3 equations. So we're still kind of stuck. But then if we're clever about it, like if we sum forces in X, right, then that's 1 equation. Sum forces in Y. If we sum torque about somewhere clever, maybe things cancel. So there is no clever choice where things cancel. If we sum torque about here, point D, then there's going to be no torque due to this force, but there will be torque from this, 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 and this. So that doesn't really help. If we sum torque about point C, that seems clever, because about point C, there's no torque from this or this. There's only torque from that, this, and this. So still, like, that doesn't really help. But let's say we choose our section in a different manner. For example, we choose our section we still want to cut through here and here. But watch, let's cut our section like this. Okay, so let me draw it more like angular. So cutting through here and here and here and here. So this is our section. It's like being clever. If that's our section, what does the free body diagram look like? I'll just draw the left side of it. So that section will look like this. And then here, 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 and then the reactions at A, and then the load here. Now, if we sum torque about somewhere clever, let's say if we sum torque about here, there's no torque from this, this, or this. There would only be torque from this, this, and this, both of these being known. So that torque equation would only have one unknown. Or we can sum torque about, let's say, point B right here. So the torque about there, the only forces contributing would be this one and this one. So that's maybe even cleverer. Okay, so then if we chose this as our section, then not this one anymore. This would be our free body diagram. So then if we sum forces in the x direction, then it's AX plus TBE plus TDG. Some forces in the y direction, AY minus TCD plus TBC minus the load F. And then some torque about right here, point B, right here. So then there's torque by AY, which is going to be, here to here is L, and that'll be torque in the negative z direction, so negative L AY, and then there would be torque from this, which is 2L, also in the negative z, negative 2L times TDG, and that's it. So the unknowns, here, here, right? So then solve for this first, then you have TDG, put it right here, solve for this, BE, and then this is still statically indeterminate. We wouldn't be able to solve this, right? That's not enough information. We're still stuck. It's still statically indeterminate. But we would know the answers for DG here and BE here. And we would not know the answers for these two. So it's like being cute about it. Like we don't know, we still haven't solved everything, but we were able to be clever and solve for the particular unknowns. Okay, so this is a little bit, I mean, it is very much academic, like a school exercise. If you're at work and you really want to know the axial forces in these two members, you don't have to be clever about it and try and find the tricky way to utilize the method of sections. You could always just switch over to the method of joints, and that would definitely, right, you just go joint to joint and solve everything joint to joint. So this is just kind of being clever about choosing a section. But it does show that different choices of sections would allow you to solve a problem that you would not be able to solve if you chose another section. Okay, so I'm not sure how much that helps or makes things worse, but I'll do more examples of maybe less tricky problems, and if you have particular requests, just put those in the forum and I'll record videos. Okay, so I'll see you in the next video.